Not really the best at explaining things, but people wanted to understand my rope physics, so I thought I would explain it to you. I have a fair bit of data they store, but to summarize it, it's just the location, if it's setting the weight of the first or last position to 0, which means it won't allow that part of the rope to move. I'm actually able to make it anchor any position along it since it stores an array of the values. The length is the total distance that rope's covering. I have my detail level, which is just how much I want it to subdivide that. The total point count it's using, the rotation, the width, the rope type, which is just the texture it's using. One moment while I head on up to the actual rope itself to show it. But yeah. What it's doing is I am storing a point number where for every point it gets that much longer. And the max length is how big each segment is between each point. Type is just texture, rotation is just rotation, since it's generating the entire segment from code when it runs. These are just things I use to attach something to the end of it. And the point weight is the amount of influence it has on the points around it and how much it'll get pulled. 0 just means that point's not moving, as I've said. Then beyond that all, we have my computator for it. What we're managing is it is loading in the rope itself, which has the ID, aka which rope it's part of, where it was the last time it updated, so I only need to update info if it actually moves a fair bit, the weight of a point, the length of each segment it should have, and where it was last. Then this one is the one that I'm pulling back to minimize how much data I need to grab. It is storing only its X and Y positions. And this is what I'm using to handle application of forces to push it outside of collisions. We've got the segments here, which I'll load it in using the default segment set. The managed data, which is just time, detail level, accuracy, and current time. The time step is used to determine how many time steps I'm making. I have it run like this, so I only need to loop it well, I'm not sure how to word it. Give me a moment. I'll explain some other stuff and get back to that one. The way I'm handling the motion is verlet integration mainly. I am getting the position. I'm getting the position. I'm getting its data. And I'm storing a temporary vector of where it is to modify. I'm storing the acceleration based on gravity. Adding the turbulence, which is just noise to make it wobble back and forth a bit as if there's some wind blowing through it. The forces, which applies every force that is within range of that point on the rope. And I'm using custom distance squared too, because optimizational hell, but it works oddly well. And then editing position, which is basically the temporary vector plus the temporary vector minus the last position it was at, adding the acceleration times the time step squared. It doesn't store any velocities, which allows me to cut out a lot of unneeded data, and it still runs fairly well. And this function right here is how I'm actually handling my collisions. Collision map includes just checks that the pixel in my image loading right here, which if I were to pop back over to here, you can see them right here, are a map where black means there's nothing, red means there is something there. I use the same thing for my light mapping, but it will take that image, check a pixel based on what pixel it should be checking. It's about 32 by 32 for the ratio. So I'm just multiplying by this since it's faster than a division to get the accurate position to be. And if it's not 0, it hits something. So in that situation, it'll usually run this function, which is where am I and where did I start at? And it's clamping where you are going to be to the cell you are in plus a slight margin, so you don't end up perfectly on the line, which caused a few issues for me, to it goes from the top left to the bottom right corner of that grid area with a slight edge, which is why I'm adding this. Just adding 32 to the other number and subtracting this number out to get this. So from there you end up with a clamped location, and then it updates the two sets of values. Once it's run that, because of a few annoyances, I basically looped through 50 times to make sure. Well, I actually took this from a set of code for 3D stuff and modified it to suit me, cut out a lot of unneeded stuff. Came out to, when I need to satisfy constraints, I'm doing it in groups of 4 for everything, so I can multi-thread it more smoothly for the shader, but it is checking that a point weight isn't 0 before it even handles the integration. If it is 0, then it just skips that point, because that point doesn't move at all to begin with. And if it handles the constraints of something, it'll run this code, where it gets the current position you're checking. It will check how far you've moved, and if you've moved less than 0.2, it just says you're close enough to where you were, and just skips you. However, the last update position only updates in here. Wait. Yeah. I'm not sure. It's fine, though. It works perfectly. I got it working. Please don't question it, but then we just get the point before it, check that they're the same rope, which is why it stores this rope ID, get the constraining forces, check they're within the grid, and if they're not, it clamps them to it, then updates them, then repeats for the point immediately after it. And the constraining forces are getting the point A, point B, the delta. This is the only time I use square root, and I still don't like that I had to use it. And then the difference, which is getting the length minus segment A's length, rest length, because they're the same rope, same rest length, divided by the length times the point weights. And then it handles adding point A to itself times point weight, point B minus its point weight times the data. Then it gets the set it needs to send and sends it back for you to handle right there. Which is a bit convoluted, I guess, but a lot of what I have managed here, the way I'm handling things like the boxes that explode, which, if I were to run it and fly on over to this stage right here, you'll notice, once I get rid of these, the boxes aren't part of the map traditionally. I actually have a separate code to manage handling updating the stuff, which I've created over here. It has a lot of code, but it creates the rendering device and the data, the thread count and everything, how much it's run so far, so you can handle things that rely on ordered running it for the same shader. The initializing function lets you set the file for the actual shader file, and if you want to run it on the render thread itself. Everything beyond that is managed mostly rather well. Like if you create anything for it, it returns you with an integer that specifies the ID of that thing. And replacing them, the way I tend to replace it is I would do format ID, the ID that it's going to be at, starting from the lowest ID, and then the creation of a new creation of the new thing. So you would have this, and if texture ID 0 doesn't or format doesn't exist yet, it'll create it and move it to that ID anyways. As long as, you know, there's no ID less than it yet, since it is stored in an array. Beyond that, it uses these all fairly well. Runs them, automatically handles the freeing of stuff it doesn't need as well. Might try publishing this one at some point. Still needs a bit better on the documentation side because it is a bit iffy there still, but yeah. I put all that together and you end up with rope that collides with stuff. So, yeah. Great pain, but it works very well. One second while I load that in, and yeah. Then you have ropes that collide, forces applied to them, and collisions. I just realized I said collisions twice. But anyway, yeah, rope.